Today I'm going to talk about page 3 and 4 and just a tiny bit of page 5 in your note packet for chapter 9. This is section 9.8, reference angles. Here's another very important concept that we'll be using throughout the rest of the trigonometry chapters this year. There's a concept that you need to be aware of called a reference angle. Every angle that you're given has an associated reference angle with it. And what we're going to do is find a reference angle for any angle that is given to us. And usually we're given it as a theta value. So here it says associated with every angle drawn in standard position, the only exceptions being the quadrantal angles, which remember are the multiples of 90 degrees. So 90 degrees, 180, 270, 360. They don't have reference angles. All of the other ones do. There's another angle called the reference angle. The reference angle is an acute angle. Remember, acute angles are less than 90 degrees. It's an acute angle formed by the terminal side, that's the ending side of a given angle, and the x-axis, and I'm giving you diagrams below. Reference angles appear in all 4 quadrants, depending on the given angle. And if you have a quadrant 1 angle given to you, then it's its own reference angle. So down here, there are 4 different examples of reference angles drawn for you. And what you have here is a quadrant 1 angle. So we're starting here. Here's the terminal side. So this reference angle right here is the angle that the terminal side makes with the x-axis. This is a 60-degree reference angle. So 60 degrees is this reference angle. It's just the given one. But this second example, here's a 120-degree angle. It ends up in quadrant 2. Well, a reference angle is an angle that makes with the x-axis, the acute angle. So this acute angle is actually 60 degrees because if we went another 60 degrees down, we would get down to the x-axis. So there's the reference angle for 120 degrees. It's 60. Over here you have a quadrant 3 angle. All the way around here, it's 240 degrees. Well, this 240 degrees has a reference angle, and remember, the reference angle is always the one that goes up against the x-axis. Well, how big is this reference angle? Well, we've gone 180 degrees, and then 60 more will give us the 240 that we were given. So this reference angle is 60. And then this last example, you are given a 315-degree angle, so this angle is actually in quadrant 4. The reference angle is the acute angle that it makes with the x-axis. So you can see all of these are acute angles. They all go up against the x-axis. And you've gone around 315 degrees. If you go another 45 degrees, you'll get to the x-axis. So if you have colored pencils, if you could color these in with different colors, that would be great. So down here, this just summarizes the reference angle is the angle measured from the terminal side of the original angle to the x-axis, but not the y-axis. You can see they're all up against the x-axis, all these reference angles. If you want to calculate the reference angle, if you're given a quadrant 2 angle, all you have to do is subtract that angle from 180. Like in this example, I was given 120. If I subtract 120 from 180, you get 60. In quadrant 3, the given angle minus 180 will give you the reference angle. In this example, I was given a 240. If I do 240 minus 180, I will get my 60-degree reference angle. And in quadrant 4, you subtract the angle from 360. So if I'm given something like 315, I just do 360 minus 315, and I'll get that reference angle. You have to just be careful. Sometimes the angles that are given to us are not between 0 and 360 degrees like all of these were. And what we have to do in that case is we have to get a coterminal angle to the given one, which means we either add or subtract 360 from what we're given. So I'll just remind you how to get a coterminal angle. You're going to add or subtract 360 degrees from the given angle. All right, that's how to get a coterminal, because what you really need to do is you need to have these angle thetas be between 0 and 360, and that's what this says. These are the angles between 0 and 360, or actually between 90 and 360, because a quadrant 1 angle is its own reference angle. So here's the example, or several of them. Here's a 160-degree angle. The first thing we're going to do is figure out what quadrant this is in. This is in quadrant 2. You can probably figure that out pretty quickly. So in quadrant 2, we just do 180 degrees minus 160 degrees, which is 20 degrees. So this reference angle would be 20. This example, 255, this is a quadrant 3 angle. So in quadrant 3, you do the angle that is given to you minus 180 degrees. And I think that's probably 75 degrees. I'm not positive, but it's probably 75. The next one, 301 degrees. Well, this is a quadrant 4 angle. So in quadrant 4, I just do 360 minus the given angle, 301. 360 minus 301 is 59 degrees. So this reference angle, so you notice all these reference angles are acute positive angles. If we're given a negative 45 degrees, that's not between 90 and 360. So we're going to have to add 360 degrees to negative 45. And if we do that, we'll get 315 degrees. Well, 315 degrees is in quadrant 4. And we've already done that way up here with this example, but if we want to get that reference angle, we do 360 degrees minus 315 degrees, which will give us a 45-degree reference angle. This next angle, 580, that's too big. So our coterminal angle, if you subtract 360 from it, you'll get 220 degrees. So coterminal to 580 is 220. 220 degrees, that's in quadrant 3. And in quadrant 3, you do 220, the given, minus 180. Oops, 220. And 220 minus 180, I believe, is 40 degrees. So there's a 40-degree reference angle for 580. The next one, negative 111. Well, I don't want a negative angle. I need to add 360 to it to get a coterminal angle. And I want to use my calculator so I don't make a mistake. So when you add those together, you're going to get 249 degrees. 249 degrees is in quadrant 3. So in quadrant 3, we do 249 minus 180. And out will pop 69-degree reference angle. Next one, negative 245, you're going to add 360 to negative 245, and you get 115 degrees. This is a quadrant 2 angle. So in quadrant 2, you do 180 minus 115, and you will get 65 degrees for the reference angle. And in this example, we're going to have to add 360 2 times in order to get an angle between 0 and 360. So if you add 720 to negative 700, you get a 20-degree angle. That's in quadrant 1. And remember, quadrant 1 angles are their own reference angle, so this reference angle is 20. When the terminal side of theta moves into quadrants 2, 3, and 4, we are going to have to find trig values. It becomes a little bit more of a challenge. What we're going to do here is we're going to follow this 3-step method in order to find the sine, cosine, or tangent. Well, we're actually not going to find these actual angles. What we're going to do is we're going to figure out what angle these reference angles are going to be. And then we're going to rewrite these in terms of another angle. So our instructions, and you'll see tomorrow in the textbook, we're going to have these instructions. It'll say express each given function in terms of a function value of a positive acute angle. And so when you have these are the instructions in the exercises that we're going to be doing in class. We're actually not going to be finding the sine or cosine or tangent because we could just plop those into our calculator and it would be really quick. But what we're going to do is we're going to figure out what quadrant in step 1 these angles are in. And then we're going to figure out the reference angle just like we did before. Then we're going to use that all students take chemistry trick to see whether or not what we're given, sine, cosine, or tangent, is going to be a positive or a negative number. And then we're going to either write a plus or a minus in front of it, depending on what all students take chemistry tells us. So what this all means is this. When you have 230 degrees, well, this is a quadrant 3 angle. And so in quadrant 3, we have a reference angle of 230 minus 180, and I believe that's 50 degrees. So there's our reference angle. So that was step 1. Step 2 says we're going to do this all students take chemistry trick, and because we're in quadrant 3, the only thing that's positive in quadrant 3 is a tangent. We're asked about the sine. Well, the sine is negative, so we're going to put a negative out in front. That's what step 3 says. Negative out in front. We're going to rewrite the trig function that's given to us, which is a sine, and then we're going to put the reference angle 50 degrees. So the sine of 230 is the same exact value as the negative sine of 50, and I'm going to show you on the calculator that this is true. And you should pick up your calculator also. I want you to put in the sine of 230 degrees. We knew it was going to be negative. Now I want you to put in what we just calculated, which is the negative sine of 50, the reference angle, and we should get the exact same number, exactly with the negative out in front. Those two are equivalent to each other. The positive sine of 230 and the negative sine of 50 are the same. And so we'll go through all of these like this. The second example, 305, the first thing we're going to have to do is figure out that this is a quadrant 4 angle. And then we have to get the reference angle, which is 360 minus 305, which is 55 degrees. So we have a reference angle of 55. Then our little all students take chemistry tells us that because we're in quadrant 4 and we're asked about the cosine, cosine is positive in quadrant 4. So the cosine of 305 becomes the positive cosine of that reference angle, 55 degrees. In our calculator, if you type in the cosine of 305, you'll get a positive number. And if you type in the cosine of, what we get, 55 degrees, it should be the exact same number, and they are. So that's our check to make sure that we're right. The next one is 110 degrees. Well, that's a quadrant 2 angle. And the reference angle is 180 minus 110, which is 70 degrees. And all students take chemistry tells us when we're in quadrant 2, the only thing that's positive is sine. Well, we're asked about the tangent. Tangents go negative in quadrant 2, so we rewrite it as the negative tangent of that reference angle, 70 degrees. And then we check in our calculator that the tangent of 110, which is that number, is equal to the negative tangent of 70 degrees, which is exactly the same thing, so that's our check. Number 4, oh, I don't like a negative angle, negative 190, so I'm going to add 360 to it. And negative 190 plus 360 is 170. So this is exactly the same as the sine of 170 degrees. The next thing we need to do is get what quadrant we're in. This is quadrant 2. And in quadrant 2, the reference angle is 180 minus 170, which is 10 degrees. And in quadrant 2, when we look at all students take chemistry, well, quadrant 2, the sign is positive. So this is a positive sign of the reference angle 10 degrees. And let's see, does the sign of negative 190 degrees equal the positive sign of 10 degrees? Well, yes, they do. They're exactly the same. The next one is negative 250. So I'm going to add 360 to that because I don't want a negative angle. Negative 250 plus 360 is 110. So I'm actually finding the cosine of 110 degrees. Well, that's in quadrant 2. The reference angle is 180 minus 110, which is 70. And all students take chemistry tells us in quadrant 2 the cosine is going to be negative. So we have a negative cos, and the reference angle was 70 degrees. So we're going to check to see that the cosine of negative 250, which is that number, is actually equal to the negative cosine of 70, which is exactly the same. And then the tangent of 200. Well, 200 is just a quadrant 3 angle, and the reference angle is 200 minus 180, which is 20. And all students take chemistry says in quadrant 3 the tangent is positive. So we have a positive tangent of the reference angle 20 degrees. And let's see if the tangent of 200 is actually equal to the tangent of 20. And it is exactly the same. So we're right. Now what we're going to do is the 30, 60, 90 or 45, 45, 90 degree special angles. If you're asked to find an exact value, it means no calculator allowed. All of these numbers that we found on our calculators are not exact, they're approximations. If we're asked for the exact value, that means no calculator allowed. No, 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 don't even pick it up. All right, so what we have to do is, just like we did before, step 1, find what quadrant it is in. It is in 135 is in quadrant 2. And the reference angle is 180 minus 135, which is 45 degrees. I knew it was either going to be a 45 or a 30 or a 60. Step 2 says, do the all students take chemistry? To see whether the cosine of a quadrant 2 angle is going to be positive or negative. Well, in quadrant 2, only the sign is positive. So in step 2, it says the sign is negative. And then up here, it says in step 3, write a plus or minus in front of it. Well, because it's negative, we're going to write a negative. Oops, I'm sorry. This should say cosine. Good God. All right, the cosine is negative because that's what we're talking about. Cosine is negative in quadrant 2. Cosine is negative in quadrant 2. So we have a negative cos. Now the reference angle is 45 degrees. And now we're going to have to pick out our blue sheet, which tells us the exact value of the cosine of 45. Well, I'm hoping that you might remember it, or maybe you could figure it out by doing a 45, 45, 90. Well, the negative cosine of 45 degrees is a negative square root of 2 over 2. Final answer. And that's it. That's exact. That is no calculator. Exactly. Not approximately. And then this last example that I'm going to give you is a cosecant of 300 degrees. Well, step 1 says, what quadrant is 300 degrees in? It is in quadrant 4. And what is the reference angle? The reference angle is 360 minus 300, which is 60 degrees. Step 2 says, we're going to do all students take chemistry. Well, the cosecant is the reciprocal of the sine. So all students take chemistry says, because 300 degrees is in quadrant 4, here's our 300-degree angle down here. Because the cosecant is the reciprocal of the sine, the cosecant is negative because the sine is negative. Because sine is negative. All the reciprocals are the same as the original. So now the step 3 says we've got to write a negative out in front and a negative cosecant of the reference angle 60 degrees. And if you want to take a look at your blue sheet, you can, or maybe you can remember, but cosecants are a little bit tricky to remember. So the cosecant of 60 degrees, way back when we did our blue sheet, cosecant of 60 degrees is 2 square root of 3 over 3 if you wanted to rationalize that denominator. So the answer is negative, and it is 2 square root of 3 all over 3, the cosecant of 60 degrees. So this is the exact answer. This is no calculator. And that's it for today.